Learning Target 4.2.1 asks us to determine whether a point is a solution to an equation. And this is kind of a huge foundation for algebra, knowing what does it mean to be a solution. And back in Chapter 3 we talked about, what does it mean to be a solution to maybe this equation? And we'd say, well, the solution is 2, x equals 2, because when you plug 2 in for x, it makes this statement true. And it's no different than when you have equations with two variables, a y and an x. You have to be able to substitute the x and y values in, and it has to make the equation true in order to be a solution. So in 4a, if we substitute 2 for x and 11 for y, we get the equation 11 equals negative 2 times the x value is 2 plus 7. We have to decide, is this true or not? Does 11 equal negative 4 plus 7? And negative 4 plus 7 is 3, and 11 is not equal to 3, so 4a, this point, 211 is not a solution because it doesn't work in the equation. In 4b, if we substitute negative 3 for x and 2 for y, we get negative 2 times x is negative 3 plus 4 times the y value is 2. We want to know, does that equal 14? Because if it does, then it makes the equation true and we have a solution. So negative 2 times negative 3 is a positive 6, plus 4 times 2 is 8. And does that equal 14? Yes, 14 equals 14. So 4b, we'd say, yes, it's a solution. Now, if we look at 4c, though, we have a little different equation because we only have one variable. We have y equals 3. Well, in that case, we really don't care what x is. X doesn't have any factor into this equation. All we care about is that y is 3. Well, if we substitute our y value in for 10 in for y, does 10 equal 3? The answer is no, so therefore this point would not be on the equation of the graph of this equation. It doesn't make this equation true, therefore it is not a solution.